Hey everybody, in this next video lesson we're going to talk about how to write names of ionic substances using those polyatomic ions, which we've just introduced to you. Now, when it comes to naming these, it's not too tricky, to be honest. All you need to do is the metal keeps its name, and the polyatomic ion keeps its name. So if you know the name of the polyatomic ion, just slap it on the end. Don't change the ending. The endings have already changed to tell you how many oxygens, for example, there are in something. So, for example, nitrate has 3 oxygens in it, and nitrite would have 2. So the name already tells you a little bit about what is going on in the molecule. So you don't need to change the name again. It's already been changed, so to speak. So it's pretty easy. The metal keeps its name, the polyatomic ion keeps its name, and you may include a Roman numeral if there is a transition metal involved, like this one down here, the Cu2SO4. Cu is a transition metal, so I know I'm going to need a Roman numeral when I name it. So let's take a look at this first one. This is aluminum, and this is hydroxide, just aluminum hydroxide. We don't say aluminum trihydroxide because, again, we don't use the prefixes for ionic substances, no matter how many of them we have. So that's pretty simple, aluminum hydroxide. This one is magnesium nitrate. Now, when it comes to writing the formulas, you have to keep in mind, once again, balancing charges. You need to make sure that the positive charges for the metal and the negative charges, now for the polyatomic ion in this case, cancel each other out. So once again, you can use that crisscross trick where you can take the charge of the one and put it on the quantity of the other, and the charge of this one, put it on the quantity of that one, and you got yourself the right ratio as long as it's in its most reduced state. So calcium phosphate is Ca3PO4 parentheses 2. Now make sure that you use parentheses here because when you have multiple polyatomic ions, you need to put the whole polyatomic ion in parentheses with the quantity outside. So it might look a little awkward because you've got PO4 and then a 2 right after it, but the parentheses separates the 4 and the 2. So just keep that in mind. If you've got multiple polyatomic ions, put it in parentheses with the quantity outside the parentheses. Now in this one, you've got lithium carbonate, or Li, which is a +1 charge, and carbonate, which is a 2- charge. And this time, I'm going to double the lithium to balance out the charges of the lithium and the carbonate. And since I only have one carbonate, I don't put it in parentheses. I just kind of leave it as it is. So some teachers might take points off if you put parentheses around a polyatomic ion if there's only one of them. But it's not necessarily a point of emphasis for me personally, so I'm not too worried about it. Try these on the bottom quick, pause the video, see if you can figure it out, and then I'll tell you the answers. All right, this first one is a bit tricky. Ammonium is one of our positive polyatomic ions, and so the ammonium formula is NH4 with a 1+ charge. And chlorate is a negative polyatomic ion, so that's ClO3 with a 1- charge. But since it's a +1 and -1, you just smush these two polyatomic ions together and you get NH4ClO3. Now this next one, as I mentioned before, is a Roman numeral type problem because it's got a transition metal on it. So we need to figure out what the charge is of this copper. First of all, we can put down copper and we can put down sulfate because it is copper and sulfate. But I need to leave room for a Roman numeral. Now we know that each sulfate is a 2- charge. And because of that, we can then deduce or figure out what the charge is of the copper. There are 2 of the coppers, so that must mean each copper is a +1 or a 1+. Now that we've determined the charge of the copper, we can write it in as a Roman numeral. So the final answer is copper 1 sulfate. Here are a couple of harder examples that I'd like you to try, and pause the video, try them, and then I'll go through the answers for you. This first one is called iron, and this polyatomic ion is hydrogen sulfate. But as we mentioned just on the last slide, if it is a transition metal, we need to figure out the Roman numeral. Well, the charge on the hydrogen sulfate is a 1-, and there are 3 of them, so that must mean that that one iron is a +3 charge. So the final name of this is iron 3 hydrogen sulfate. Next, we've got MgCO2. Now CO2, you might think is carbon dioxide, but it's not. It's a polyatomic ion that's attached to magnesium. This is carbonate with 1 less oxygen, so this is carbonite. So we've got magnesium carbonate. No Roman numeral necessary because magnesium is not a transition metal. This next one is a transition metal. Once again, we've got tin, Sn, that is tin. And this polyatomic ion is dihydrogen phosphite. Phosphate would be PO4. This is PO3 with 2 hydrogens out front. So it's dihydrogen phosphite. Once again, we need to leave room for a Roman numeral. Now, what is that Roman numeral? Well, phosphite is a -3 charge, but there's 2 hydrogens out in front, so dihydrogen phosphite is just a -1 charge. And there are 4 of them. So 4 -1 charges results in 1 tin being a +4 charge. So the final answer is tin for dihydrogen phosphite. Down here in these examples where we're writing the formulas, we need to, just like we did before, make sure that we have the correct charges before we can balance the charges to figure out the correct combination of cations and anions to make the ionic compounds. So aluminum here is a +3 charge, and pernitrate is NO4 with a 1-. And so when you put that together, you need 3 of the pernitrates for every 1 aluminum, so it's AlNO4 parentheses 3. Now this next one, ammonium carbonate. Ammonium, once again, is our positive polyatomic ion. It's NH4 with a +1 charge. And carbonate is another polyatomic ion with a -2 or 2 negative charge. So that's CO3, 2 negative. Now since I have a +1 charge ammonium and a -2 charge carbonate, I need 2 ammoniums for every carbonate. So I put ammonium in parentheses with a little 2 behind it. So it's NH4 parentheses 2 CO3. Finally, sodium hypochlorite. Sodium is a +1 charge ion, or 1+. Hypo means that we have 2 less oxygens than the normal 8. So chlorate is ClO3. Hypochlorite should be ClO with a -1 charge. So we've got a +1 charge and a -1 charge, and that results in just NaClO. Well, that takes care of this video lesson on naming using polyatomic ions. Thanks for watching.